This is CPM Precalculus, Chapter 3, Number 8. So given the graph of f of x, right, this is f of x, find expressions that will generate the graphs below in terms of f of x. So let's look at part A. So part A, we have this graph right here, right? So we have to basically look at the original f of x and see how did it become the new graph, right? How did it become here? What transformation took place? So what you have to do is put on your thinking cap and just analyze the graph. So what we start with here, this point right here, right? You can label certain points. This is 0, 4, right? 0 to the left and right, up 4 units. This point right here is to the right 2 units and up 2 units, 2, 2. Right? I'm just looking at some critical points where we're changing, right? Where the line changes. All right, this point here is -4, -4. -4, -4. Now let's go ahead and do that same thing on our graph here and see if we see any patterns. So that point here is 0, 2. So I see right away that it went from 4 to 2, right? The y value, the height, it's still at 0. It went from 4 to 2 though. All right, this point right here, the critical point where the direction changes is now 2, 1. And I see it went from 2, 2 here to 2, 1, right? Has the same general direction, but I see now that we are doing some type of compression, pushing the graph like from top and bottom and compressing it inward, right? Finally, this point here is now -4, 1, 2, 3, 4. -2. -4, -2. So I see all of the x values, right? 0 here stays the same. 2 here stays the same. For the critical points, all the x values, -4, stay the same. The only values that are changing are the y values. 4 becomes 2. So the y values, right? Y values from the original graph to the new graph, right? The y value comes 4 to 2, 2 to 1, and -4 to -2. So you have to see a pattern. If you multiply 1/2 times 4, you get 2. If you multiply 1/2 times 2, you get 1. If you multiply 1/2 times -4, you get -2. So the y values being multiplied by 1/2, right? So that's going to tell us right away that the y values being multiplied by 1/2 means it's a vertical compression by a factor of 1/2, like it's our vertical stretch, compress, by a factor of 1/2, right? And how do we write that? So that means our new graph, let's call it y, right? This is y here, is just equal to a vertical stretch by a factor of 1/2 means we multiply 1/2 in front of f of x, right? We multiply in front 1/2 times f of x, and that gives us the vertical compression by a factor of 1/2, okay? So this right here is part A. Y is equal to, in our graph, 1/2 times f of x. Let's go on to part B. All right, this is part B. Here's our graph. So we want to do the same thing, okay? So let's go ahead and this time I'm going to label these points and make it so these values stay. So again, this is 0, 4 here, right? This point is 2, 2, and this point is -4, -4, right? Over here in our graph now, this point right here, the critical point, see how it has the similar shape, like it's starting low, going up, going down, and remains like at the height of 2. Well, this point is still 0, 4, all right. This point now, though, is changed from 2, 2 to 1, 2. And this point here went from -4, -4 to -2, -4, right? So what happened? Well, again, we see a type of compression, but this time it's a horizontal compression, right? We're pushing in, well, actually, we're pushing in over here on f of x. We're pressing inwards on the left and right sides, and this graph is getting a little skinnier, right? That the x value is the one that's changing. 2, we multiply 2 by 1/2, right? Times 1/2. The 0, well, 0 stays at 0, so we could say that's being multiplied by 1/2 as well, times 1/2. And the -4 over here is multiplying by 1/2 as well, right? So I can go ahead and say the x values are multiplied by 1/2. And remember, when we look at the x values changing, that's the same as a horizontal stretch or compression, right? Compression means it's being pressed in. Stretch is when it's being pulled out. So this one would be a compression, horizontal compression by a factor of 1/2, right? And so that's going to give us the equation for the new graph. Y is, remember, a compression means inside the parentheses, right? So inside the parentheses, we want to go ahead and say 1/2 x. But remember, we have to do the reciprocal of what we're going to multiply it by. So if we want to compress it by 1/2, we're going to have to multiply it by the reciprocal of 1/2. The reciprocal of 1/2 is 2 over 1. 2 over 1, we can just write 2. Okay? So this right here, multiplying it by 2 is going to be, again, the reciprocal of 1/2 here. Okay? So this is the new function that we have graphed. All right. So finally, let's go on to part C. Part C, here we have a graph that looks like this now, right? Well, when I look at these, at first I could see, well, this point here is still 0, 4, but this point is no longer up here, right? It's now at 4, -4, right? We're going 4 to the right, down -4. This point is no longer down here. It is -2, +2. So what happened? So what happened starting at f of x over here, right? This is f of x, and going to our new graph here. Well, if you look closely, right, you're going to see that this is actually a reflection across the y-axis, right? If you reflect it and you make it like a mirror, this point here is going to shift to the other side, and you're going to draw it that way, right? If you make the y-axis a mirror, right? This is a mirror, right? That means we're just reflecting the graph across the y-axis. So we go like this, right? This kind of piece does the same. 1, 2, 3, 4, right? So going like this. So I'm just kind of drawing that reflection, right? And you see that that's what we get here. So this is a reflection mirror across the y-axis, right? Well, in the past, we've seen reflections across the x-axis, right? We have a mirror and switch everything from one side to the other. But a reflection across the y-axis now, when we're reflecting across our y-axis, that changes inside the parentheses, right? And we make that a negative x, and that's going to represent the reflection across the y-axis. All right, so let's box that answer. And there we have the end of CPM Precalculus Chapter 3, Number 8.